Okay, folks. So, in this session, we are going to talk about agents, but this time we are going to focus on something new has come up in last few days called Agent Hospital. What do I mean by Agent Hospital? It's the hospital which is run by LLM, and particularly it's run by LLM and LLM agents. So it's completely new. A new research paper has come out a couple days ago by a researcher based out of China, where they are envisioning an hospital ran by agent. So let's dive in. So what do we mean when we say agent hospital? When we say agent hospital, as I was saying earlier, it is completely ran by agent, where a patient could walk in and then at the reception there is an agent which is run by LLM. There is a nurse who is triaging, there is a doctor who is examining, there is a further doctor who is probably treating and dispensing the medicine, and hopefully that patient goes home within few minutes. What they have been doing as a part of this is all simulations, right? So don't worry, there is no such hospital exist in China which is run by LLM, but this is the researcher's point of view that what if we want to run this kind of a hospital? Again, I'm not saying in China or anywhere else. Maybe this kind of hospital may not be possible in the developed country, but it could be possible in the remote villages where there is a lack of doctors, there is a lack of nurse who can treat people well, who can at least examine the people as they are walking into the hospital, do some primary analysis, and then guide them that, okay, based on what you are telling us, this is what we think you should go for. We think you have a flu. If you think you have COVID-19, that's a different story. All right. So again, this is all simulations. They have done these simulations against approximately 10,000 records. And the interesting thing, what they found at the end of the day, that the agent, the doctor agent, who are kind of LLM agent, which is doing the function of a doctor, is improving their knowledge every day. Now, you may wonder that yes, we human as well, we improve our knowledge every day. Even as a doctor would improve their knowledge every day, because as they are learning new things from different patients, they are increasing their knowledge. Yes, but we will take a look at what it takes for a human doctor to gain that knowledge or improve that knowledge from a time point of view versus what it took these agents to improve their knowledge from point A to point B. All right, so let's dive in further. Particularly in this example, what we are looking at is there is a patient who is walking in. This is a simulation. They are walking in and saying, hello, I have symptoms of a dry throat, a sore throat, cough, a mild fever, and a runny nose. Now, they are just walking in, so somebody has to triage it. Typically, that is how in a hospital it would happen, where as you walk in, somebody would triage it where you need to be sent to. They won't treat you right there and then in the entrance, but they will send you to somewhere else. So in this case, the nurse is saying that according to your symptoms, I recommend you go to the internal medicine consultation room, which is fair. Nurse is based on the symptoms. It's saying, okay, you need to go here. But in both scenario, remember, this is a simulation. So patient is also a simulation. It's a simulated patient, and nurse is a simulated as well. So there is a nurse agent, there is a patient agent. For both, each other are interacting with each other, and based on the symptoms, the patient is being forwarded to the next stage. Now, there is another way of looking at it. Different patient is saying, okay, my blood test information is so and so. Now here, this is not a symptoms, but this is a blood report, right? So that's a differentiation here. using the blood report, the patient is showcasing and giving out to the doctor saying that this is my blood report. And the doctor agent, again, this is an agent based workflow, is saying that based on that examination result, what I just looked at it, and the symptoms what you are depicting, I think you may have a mild COVID-19. Now, in this scenario, the doctor is not just relying on the blood report, the doctor is also relying on the symptoms. So combining two information almost in real time, right? Because symptoms is almost real time. The report may be a few hours old. So using few hours old report, using real time information from a symptoms point of view, this doctor agent is combining all this together and figuring it out what the user has or the patient, the problem patient has. Okay, if you remember, few days ago we talked about agents, and the most common thing in the agentic workflow, LLM based agentic workflow, you need to do, or you as a designer of a system needs to do, is planning. So in this scenario, this is an agent hospital. The hospital is run by agents. In this scenario, the planning would be, what is that flow look like from a patient point of view? And we looked at the flow in the very beginning of the show here. But if we look at again, as soon as a person enters the room or the hospital, they get triaged. Once the triage is done, they get registered that you are the patient. They get consulted into a consultation room. Once the consultation is over, they get medical examination, maybe a blood report, maybe a temperature check, body temperature check, or blood pressure test, or whatnot. Once the medical examination is done, then a diagnosis has to happen based on the result of that examination. Based on the diagnosis, a medicine has to be given out. Now, in some countries like US particularly, you don't get medicine right there in the hospital. Typically, a doctor would prescribe a medicine and you go to a pharmacy and you pick up that medicine from the pharmacist. In many other countries, like when I used to live in India, doctor himself will give you the medicine. Still, probably there are many doctors in India who would give you the medicine from their drawer. Yeah. But they can also prescribe and you can go to the pharmacist and pick up this medicine. But you get the medicine dispensed and hopefully you go home happy. So that's the planning stage. As a part of this planning stage, there are few things happening, right? So if you look at the patient itself is coming in, walking in, but somebody has to triage. So you need an agent there. Somebody needs to register the patient. So you need an agent there. Somebody needs to do a consultation with the patient. So you need an agent there. Based on that consultation, they may need to go to medical examination, or they may not need to go to the medical examination. They may need to go somewhere else. Who knows? But to do that examination, you need an agent. Based on the report, somebody needs to read that report. So you need to diagnose it. For diagnosis, you need an agent. Based on that diagnosis, you need to treat that patient and you need to dispense the medicine. So you need somebody who is dispensing the medicine for that user or the patient. And the patient walks out the hospital. So that's your planning process, assuming you are doing this entire thing using agent workflow. That is what this research team has done, where they came up with this workflow from a planning point of view. And then they evaluated, they brought in more data, and then let's look at what exactly they've been through. So as a part of that process, they applied certain methodology, and which is very common what a human doctor would do as well, where as soon as the patient is asking something or a query of a patient, the doctor would typically review few things, maybe a blood report, maybe a symptoms. So in this scenario, we are talking about retrieving the medical records. At the same time, retrieving the experience, right? So in this scenario, the doctor who is, let's say, a human doctor, they have gone through so much training, right? They've studied for 4.5 years, then they did their masters, then they did their internship, and then probably they have experience of few years before they actually do the independent practice and whatnot. So let's assume that this doctor has about 10 years of experience in the field. And suddenly, based on that experience, it's applying its logic that, okay, I have seen something like this in 3 months ago. Use that experience, use the records from this patient, use the symptoms, and apply heuristics, logic, whatever you call it, and doctor do an examination. Same logic applies here, as this team have designed that medical agent is applying the experience. And when we say experience, this agent is trained with up to 10,000 different records of different patients. So that means they have been trained to understand 10,000 different patients, what they have gone through. Maybe a sore throat, maybe a headache, maybe a fever. And based on that, what examination needs to be done, what treatment plan has to be designed, and what the outcome should look like. So all of this has gone through in the LLM. So that agent is applying that experience, applying the records, retrieving the records from real-time information, and using symptoms to generate what we call an answer. It's similar to a ChatGPT would generate an answer when you prompt something. Same thing, these three things are prompted to that agent, and agent is coming up with an answer. Now that answer is getting evaluated. And based on the evaluation, whether a human doctor is required or not, that decision is being made. Right? So that is the methodology this team has applied, and it's working out very well. How good it is let's take a look at, first of all, the training data. So when we say training data, particularly in this scenario, they have applied up to 10,000 records for each of the three categories. The first category is the examination accuracy. And when you say examination, is examination record. Okay, I'm examining the patient. Do you have a fever? Do you have a headache? Some sort of a question answer, or using the stethoscope or using the blood pressure meter examination. Then the diagnosis. That, okay, based on the input, I think the diagnosis is not COVID, but it's influenza. And based on that, I'm going to treat you for an influenza. So that's the third category of an influenza, as a treatment plan for this patient to go through. Now, as you see in the chart on the screen here, for each of this category, as the number of records are increasing, the accuracy goes higher. What does it mean is, if we are able to provide more input, more quality training data to these agents, this agent would be able to perform better. So as we see, the prediction accuracy of an examination, for example, is in the north of 80-85% as soon as you go from 6,000, 7,000 records onwards. What if we are able to feed, instead of 10,000, maybe 100,000 records? Suddenly that 80-85% may notch up to 87, 88, or maybe 90%. Depends on how good the qualitative data is. So that means more the data, better the output. But we want to achieve 100% accuracy, wouldn't we? Right? Because they are making decisions, these agents are making decisions for our life. What if there is some reaction may happen based on the wrong examination or a wrong diagnosis or a wrong treatment plan? Yeah, there are a lot of risk. So we need to feed more information, we need to feed more data to get to a higher accuracy. But again, this is a research project which they did as a simulation, not on any human, right? So as a simulation, okay, that's fair. So this is a workflow. We did work, particularly in this scenario when that patient is walking in with this kind of symptoms. This different task, like the examination task, is examining based on the retrieved experience of whatever it has learned as a part of that examination data. And it's also using the records of that patient. That, okay, based on that, I think you need to go through a blood test. That's fair. That is, many of the time is a very common examination being done. That, okay, based on this, we need a blood work. And then based on that blood work, the diagnosis happens. And as a part of the diagnosis, the agent is again going through the experience because it has learned of 10,000 records. So it's retrieving from those experience. Plus, it's also retrieving the top 3 relevant example from the record library. What does it mean by record library? There are, based on the diagnosis, what has been done based on the blood report, that most common cases are going to be this, that you have a high blood sugar. Okay, that means you need some insulin, or maybe you need an exercise, right? So based on those, they are going to retrieve the top 3. In this case, 3 is their example. It could be a top K being 10, 20, whatever you decide. And the diagnosis is done. And based on the diagnosis, maybe it's a high blood sugar. That means you need to give this patient some form of a medicine, which they can orally take it, or maybe you need to put some insulin injection into that user's patient's body so that the blood sugar could come down, and give them a dose of exercise of doing it every day for an hour or 2, depends on whatever that treatment plan comes down to. So that comes to the third point of a treatment task. Again, it's retrieving from the experience, because for treatment also it's been trained with the 10,000 different records. So it's using that brain, allowing that record to be retrieved based on that information, based on the past history of a patient. It's identifying and then giving a treatment plan. So you may wonder, how did it performed? Well, it performed better than some of the common vanilla model what we have seen, like GPT 3.5 or GPT 4. What do I mean by that? Particularly in this scenario, they still use GPT 3.5 and GPT 4 to build these agents. So the agents behind the scene is still using this large language models like GPT 3.5 and 4 to come up with an answer, to generate an answer. But to come up with an answer, they are prompting something different with a newer information, with the patient data, with a retrieval information, what the examination has been done from a blood report point of view, and then generating the information using GPT-4. So there are other model have been trained in similar functionality, like there is a model called MedAgents. There is also another model is MedPrompt. Both are in the range of 73 to 91% accuracy based on where we are looking at it. But this research model, what this team was working on, has come to an accuracy of 84.72 when they use GPT 3.5 versus almost 93% accuracy for GPT-4. Mainly, their dataset was on the respiratory disease. So, COVID-19, influenza, and related diseases is where they were focusing on. So, what could be the outcome, right? I mean, this is all simulation, but what I see is from here onwards, assuming somebody is going to build an agentic workflow for an hospital at some point, and not far in future, I'm not looking at few years down the road, I'm looking at few months down the road, somebody is going to apply this in field. Maybe not 100%, may not be an entire hospital is agentic, but maybe a nurse as an agent, or a doctor as an agent, or a dispensary, the medicine dispensary as an agent, or a combination of some of this as an agent, and allowing the patients to go through diagnosis faster. Why? Because there are so many places in the world where there is only one doctor within 100-mile radius. What patient could do in that scenario? It's better to get diagnosis done by a system instead of waiting for the doctor to come and do the diagnosis, or go to the doctor and wait in the line for 18 hours before their turn comes in. Another finding what they had is in terms of the time for this agents to learn. What do I mean by? when the agents are learning in the field every day, like human is learning every day in the field, but the pace at which these agents are learning is astronomically different than what the doctors would learn. Typically, human, it would take about 2 years for a human to learn what agents were able to do it in just few days, right? So then there is a time factor that, okay, if we are able, or agent is able to do all of this, not only learn but also diagnose and treat these patients in just few days, I think we can have some aspect of agent in these hospitals. May not be in the hospitals where you have ample manpower, ample doctor, ample nurses, but the remote places where literally there is no doctor. Okay, finally, last but not least, the accuracy of this is way higher. And when we say way higher, they are comparing as a base MedQA dataset. MedQA dataset is used typically for when somebody is appearing for a US medical examination to be a doctor in US. They have to go through the MedQA, and this model actually achieves that state-of-the-art performance to support that, yes, it can be a US medical doctor. All right, so with that, I conclude this session. Hope you learned something about agent. I'm very passionate about agentic future with LLM. And in this case, we looked at how an entire hospital can be an agentic. All right, stay tuned and thank you for your time.